Okay, well then I'll collect the quiz. So we are doing a test today. But I wanted to make sure we had some time to review here first. Somebody pick an odd number between 7 and 17. 15, that works. So if I ask you, what is the sine of angle B? What's it going to be here? Well, you can look it up. So there's angle B. Sine is what sides? Yes. Sine is opposite of our hypotenuse, so that would be the 112 over 113. And it's just fine to leave it as a fraction. What is the secant of angle A? Secant is a hypotenuse over adjacent, so that'll be, for angle A, the hypotenuse, of course, is 113. For angle A, adjacent would be 112. Cosine of angle A. Cosine's adjacent over hypotenuse. Good. So for angle A, that would be 112 over 113. Tangent of A. Tangent's opposite over adjacent. Very good. So for A, that would be 15 over 112. Cotangent of B. You got it. 15 over 112 again. Since A and B are complements, these two angles are complements, the tangent of one has to equal the cotangent of the other. What if I tell you that sine of angle A equals 0.65? To find A, we would do an inverse sine. Now, inverse sine can be written several ways. We usually write it like this because that's the way the button looks on the calculator, right? Sine -1, where these inverse sine and the sine cancel out. Well, there's other ways to write it. You can write it like this, inverse sine, or you could even write it as arc sine. All of them mean the same thing. How do we find the inverse sine of 0.65? There you go. 40.54 degrees. What if I wanted to find the arc tangent of 2? That's just the inverse tangent. 2. You got her, 63.43 degrees. What if I ask you to find the cosine of 21 degrees? Careful. 0.9336. Okay. Cosine of 21 degrees, just punch her in. What if I wanted to find the cosecant of 42 degrees? What function do we use? Sine of 42. Is the x -1 go inside or outside the parentheses? Outside. 1.4945. Did the sine of 42, then outside the parentheses, you hit that reciprocal key. X negative 1 left side, about third, fourth key down. Nope, it shouldn't be a second key. Oh, I can't. Right above the 7. You bet. So how about secant of 112 degrees? Negative 2.6695. Okay. Any questions on how you find those? What if I give you the secant of angle A is 1.5? Well, it's inverse cosine 1.5, but the reciprocal key, the x negative 1, is inside the parentheses when we're doing an inverse. Perfect, 48.19 we'll call it. Degrees. Any questions? Given those choices, cotangent of 78 degrees is equal to which one? Tangent of 12, good. 78 and 12 are complements. They add to 90 degrees. Tangent of one equals the cotangent of the other. Sine of 59 degrees is equivalent to what? Cosine of 31. Sine of 116 degrees is equivalent to it would be equivalent to the cosine if there were complements, but 116 is bigger than 90, right? But these two are supplements. Remember on our unit circle? 64 degrees is right here. That's its sine. There's another spot over here that has that same sign. This angle would be 64 degrees still, which makes this angle 180 minus 64, or 116 degrees. So the sine of 116 and the sine of 64 are equivalent. I'm just going to assume you guys remember the law of sines and cosines on the quiz you just turned in. So let's look at some of your applications. Let's say I tell you that this here has a diameter of 12 millimeters. This one here has a diameter of 3 millimeters. And this angle here is 48 degrees. I want to know that angle right there. How would I find that angle? Well, we don't see any right triangles in this picture, do we? We have to make some. Remember some of our strategies? We look for the intersection of vertical and horizontal. Those always form right angles. Do we have any intersections of vertical and horizontal components here? No. Second, in a circle, we look to a radius to a tangent. Do we have tangents here? Yes, we do. We've got two of them on this circle. This radius will form a right angle there. This radius forms a right angle there. That doesn't make a right triangle though, does it? We can cut that right through there. We know that. What does this angle here become? 24. It cuts the angle in half. So now we have a right triangle. Do I know any of the sides of that triangle? 6 millimeters is the radius of the circle. What I would like to know is I want to bridge that somehow over here to this circle. That point of tangency will be the same spot there, right? I'll be making this triangle here. So if I could find this length, I would have a length in this other triangle. That'd be a start. So let's find that purple length. According to my 24-degree angle, the 6 millimeters I have is which side? That's the opposite side. The purple side here is the adjacent. What trig function deals with opposite and adjacent? Tangent. Tangent of theta is opposite over adjacent. Do I know theta? Yes, 24. Do I know the opposite side? 6. The adjacent side I'm going to call x for now. So to find that, I just put this over 1, and we'll cross multiply and divide. 1 times 6 is 6, divided by the tangent of 24. Gives us 13.476 for x. So this length is 13.476. Do I know anything else about that triangle? I know this is 1.5. So I have 1.5 and I have 13.476. I can find that angle. I'll call that angle A for now. According to angle A, what sides do I have here? Opposite and adjacent. So we're still dealing with tangent. We do not know the angle. The angle is A. Opposite is 1.5. And the adjacent, 13.476. Now, up here, we were looking for a side. So we did the cross multiply and divide. Down here, however, we're looking for an angle. When we're looking for an angle, we do inverse trig function. We did a tangent, so we're going to do an inverse tangent. So tangent, inverse tangent cancel out. A equals the second tangent of 1.5 divided by that previous answer. Is 6.351 degrees. We go 6.35 degrees. What's angle theta then? You got it. That times 2. 12.70 degrees. What do you guys think? You lost? Where'd I lose you? Pretend those are evenly spaced holes. On a circle with a diameter of 42 millimeters. How do I find the distance center to center from one hole to the next? Get a ruler. If I go from the center of my circle and I connect the center of the circle to the center of those two holes, the green lines I just drew in there will be radii, correct? So 21 millimeters each, half my diameter. This angle here will be 60 degrees. How do we get 60? You got it. 360 degrees is a full circle. There are 6 of those spaces. 1, 2, 3, 4, 5, 6. So divide by 6 gives you 60 degrees. That is not a right triangle. Well, yeah, I was going to say, what we've done before is we've cut it like this, right? Then we used that right triangle, cutting this angle to 30 degrees. We found this distance and we doubled it. But now we can actually find x directly from our law of cosines, because x squared equals 21 squared plus 21 squared minus 2 times 21 times 21 times the cosine of 60 degrees. If I multiply that all out, x squared equals 441. Then what do we do? Square root it, right? Get the square of the squared. X equals 21 millimeters. Everybody be able to come up with the 441 when you punch it in? You can just punch her in as a string. 21 squared plus 21 squared minus 2 times 21 times 21 times cosine 60. Make sure you do it all as one big long string. Don't stop and hit equals at any point along there or it will mess you up. I'm going to give you guys one to try. Of course. Actually, you know what? I'm not going to give you the 36. I'm going to do this instead. Find the missing angles. Tell me where to start. Which angle do you want to find? We found C. Okay, let's find C. So when we set up our equation, what number goes in the front side of the equation? 48 squared, of course. Right? So, things we can combine. We can do the 48 squared. 2304. We can combine 35 squared and 19 squared. Sounds right. And it is 1586. And then we combine 2 times 35 times 19, which is 1330 times the cosine C. Now we're just solving the equation. We're going to subtract the 1586. Now, almost every time we've done this before, we've got a negative number on this side over here. This time we do not get a negative number. We get a positive 718 equals negative 1330 cosine C. Now what? Don't add, divide. That's multiplying the cosine, so we're going to divide by it. So 718, oops, get back here, divided by a negative 1330 is negative 0.5398 equals cosine C, and then inverse cosine. So C equals, second cosine, 122.67. How many of you had 122.67 degrees? C, good. One of you at least? So you can see there, the cosine, it'll give you an obtuse angle. It's just a negative cosine. What's that? My one disappeared, thank you. Now, which angle do I want to find next? Well, normally we'd look for the angle opposite the smaller side. Here it doesn't matter. No, that's already an obtuse angle, so no, the other ones are going to be acute. Let's just stick to form. We've got 48 over the sine of 122.67 is going to equal, use the smaller side, 19 over the sine of A. Cross multiply and divide. Sine of 122.67 times 19 divided by 48 gives us 0.3332. And of course, we have to inverse sine that. Sine equal, or A equals the inverse sine of 0.3332. 1946 sounds good. 19.46 is A. Yes, 180 minus 122.67 is going to be 57.33. Minus 19.46 is going to be 37.87. What do y'all think? Yes, you do. I will pass out the test for you.